Today we are going to discuss about one of the applications of stack, that is conversion of an infix expression into postfix expression. First of all, what is an infix expression and what is a postfix expression? A plus B is an infix expression because operator is placed in between both the operands. A, B plus is a postfix expression where operator is placed after both the operands. Because it is a very simple expression, automatically we can convert an infix expression into postfix expression. For example, let us take one more example. A into B plus C. This is an infix expression. You wanted to convert it into a postfix expression. Normally, we convert higher priority operator first. So, the sub expression which involves higher priority operator A into B. A, B into. So, as far as this is concerned, A, B into is the postfix expression. Then plus and C. So, this is considered as an operand and this is considered as an operand. And finally, A, B into C plus is a postfix expression. Let us consider one more example. Example 3. A plus B into C. So here again the same fashion, B into C will be converted first, B, C into, then A is an operand plus C is an operator, B, C into will be considered as another operand. Now the postfix expression is A, B, C into plus will be your postfix expression. For example, let us consider one more example. Example 4. Let us take A into B plus C into D. Now A into B into here also C into D, then there is a plus. So asterisk, that is multiplication having higher priority. So AB into CD into, so this becomes an operand and this becomes an operand and there is an operator. AB into CD into plus will be your postfix expression. Let us consider one more example. Example 5. A plus B into C plus D. A plus B is within parenthesis, C plus D is within parenthesis. So expressions within the parenthesis has to be solved first. So A plus B, AB plus then CD plus then there is an asterisk. This is an operand and this is one more operand and AB plus CD plus into will be your postfix expression. In this fashion, we can convert an infix expression into postfix expression. Infix expression means operator is placed in between both the operands. Postfix expression means operator will be placed after both the operands. Because as we have human intelligence, automatically here on paper we can convert an infix expression into postfix expression, but we need to convert any expression, whatever the expression is given in infix, into postfix expression using a program. So how to convert an infix expression into postfix expression, I'm going to explain by taking an example. See here, let us consider an infix expression A plus B into C. So it is taken as a character array. Character array. So it is a string. Character array means nothing but string. If you consider the infix expression as a string, string means it starts at location 0. Anyway, it is an array. Every array starts at index 0 and ends with backslash 0. It is null character. Every string ends with null character. We know where the string starts. So it is starting at location 0. What is the end of string? End of string is null character. End of any string is null character, right? End of any string is null character. So we are considering the infix expression as an array, as a character array, and we are going to convert this infix expression into postfix expression. See the procedure, step by step procedure. So here this we are considering as an application of stack. So we are using a stack. We are using a stack, define a stack, and then initialize to empty. Initially it is empty stack. So define a stack and make it empty. And what are the operations of stack? You can push, you can pop, you can find whether it is empty or not, etc. So once you define a stack, make it empty, then start reading the symbols one by one or characters one by one. Read the first character A. So it is symbol A. We read A. So these are the steps, right? First step, read symbol. What is the symbol? That is first character of the infix expression. Check whether it is operand or operator. See here, A plus B into C means A is operand, plus is operator, B is operand, asterisk is operator, C is operand, and backslash 0 is end of the string, end of the infix expression. So A. Once you read the first character, we check whether it is operand or operator. It is an operand. If it is an operand, simply add it to postfix expression. The stack is empty only. There are no characters in the stack. Then read next character from the infix expression plus. Is it an operand or operator? It is an operator. If it is an operator, don't add it to postfix expression. You have to push it onto the stack. You have to push it onto the stack. Before pushing it onto the stack, you have to check, is stack empty or not? Yes, stack is empty. If stack is empty, without comparing anything, simply push it onto the stack. So push. Then read next character from the infix expression B. Is it operand or operator? It is an operand. If it is an operand, just add it to postfix expression. Already in postfix expression A is there, and just in the next position place B. And now stack contains plus. So stack contains only one character. Then read next character from the infix expression asterisk. Is it operand or operator? It is an operator. Because it is an operator, don't add it to postfix expression. Instead of adding it to postfix expression, you check whether stack is empty or not. Stack is not empty. Stack contains one operator. Stack contains one operator. So is top character of the stack having higher precedence than this character? Now we have two operators. Whatever the operator having higher precedence, we have to use it first. So here plus asterisk. Plus is the first character that is used in here, that is read in here, and next character is asterisk. So already the previous character is placed in the stack. Is top character of the stack having higher precedence than asterisk? No. Plus is not higher precedence than asterisk. So just push asterisk to stack. So now stack contains two characters. Then read next character C. Is it an operand or operator? It is an operand. So add it to postfix expression. Stack contains two operators. Then read next character backslash 0. So backslash 0 is indicating that end of the string. Our infix string is over. Once the infix string is over, pop. Once the infix string is over, pop characters from the stack. There are two characters in the stack. Pop asterisk, add it to postfix string. Pop plus, add it to postfix string. So we have applied two pops. Pop string, pop stack, and again pop stack two times because there are two characters. Still stack becomes empty. Pop all the characters and add it to postfix string. You wanted to make it as a string, add one more character, that is null character. So here like this, a b c into plus, then last character of any string should be backslash 0. Now this becomes your postfix expression. So infix expression is a plus b into c, then postfix expression is a b c into plus. Whether it is correct or not, just find out. A plus b into c. So b into c will be converted first. B c into, then a is there, plus is there, a is an operand, b c into is another operand. Now a b c into plus will be your postfix expression. A b c into plus is your postfix expression. Let us explain one more example. See here, a into b plus c. So next infix expression is a into b plus c. So it is null character. Any string, whatever the array, character array, last character of any character array or a string is backslash 0. It is null character, which indicates that end of string. Here we are going to convert this infix expression into postfix expression. We are going to use stack. So initially we define a stack and we make it empty stack. Keep on reading the characters one by one. First read a, then asterisk, then b, then plus, then c, then backslash 0. So we start reading characters till we reach null character. We start from 0 and we end with backslash 0. So every time you read, you have to check whether it is operand operator. First read the character at 0 location, index 0. So infix expression, 0th character, that is first character is a. Read it. So it is a. Is it an operand or operator? So whatever the symbol you read, first you have to check, is it operand or is it an operator? If it is an operand, simply add it to postfix expression. Stack is empty only, no characters are there. Then read next character, asterisk. Is it operand? Is the character you read is an operand? No, it is an operator. As it is an operator, check whether stack contains any operators already. No, stack is empty. Just we made it empty right now. So stack is empty. No characters are there. So we are not going to compare this character with any of the other characters that are there in the stack. So push it onto the stack. Push asterisk to stack. So stack contains now asterisk. Now read next character B. So B. Is it an operand? Yes, it is an operand. Add it to postfix expression. Stack contains asterisk only. Then read next character plus. Is it an operator? Yes. It is not an operand. It is an operator. If it is an operator, see here. Here you have to understand properly. If it is an operator, you have to push it onto the stack. Before pushing, you have to compare this with the topmost character of the stack. What is the character? Is stack empty? No, it is having some characters. So compare plus with top character of the stack. Is stack top has higher precedence than the character or operator we are having? We are just read. So the character already we have pushed into the stack is having higher precedence than plus. See here, the topmost character of stack is asterisk. The character we read is plus. So the operator asterisk having higher precedence than plus. So asterisk has to be utilized before plus. So pop stack, asterisk is popped and added to postfix expression. Is there any other character in the stack? No characters are there. So add or push plus to stack. So plus is pushed onto the stack. Then read next character C. C. Is it operand? It is an operand, not an operator. So if it is an operand, simply add to postfix expression. Now stack contains only one character. Then read next character backslash 0, which indicates that end of the infix expression. Once you reach end of the infix expression, simply pop all the characters from the stack, that is pop plus, and add it to postfix expression, so that a b into c plus will be your postfix expression. You wanted to make it as a string, add one more character, that is \0, null character. Add a null character. So that A, B, C into C plus \0 will be your postfix string. Whether it is the correct answer or not, please check. A into B plus C. A into B will be converted first. AB into, this way becomes an operand, plus C. This is an operand. AB into C plus will be your postfix expression. AB into C plus \0. So this is what we perform on paper with pen, and this is the actual procedure to convert an infix expression into postfix expression. The sequence of steps we have followed in here forms the algorithm. So let me explain one more example also. See this third example. Assume that A into B plus C into D is an infix expression. A into B plus C into D. As we are considering this as a string, the last character is null character. So it is an array or a string. Array means character array. It is a character array which is nothing but string. Every string last character is \0, which is null character. See here again, start reading the characters one by one from position 0 to null character. We start reading characters from first character to last character. Last character is null character. We read from 0th character, that is index 0, and we keep on reading the characters till we reach null character. So we read A, then asterisk, then B, then plus, then C, then into, then D, then \0, null character. So while reading each and every character, we check whether it is operand or operator. If it is an operand, we simply add it to postfix expression. If it is an operator, we have to push that operator to the stack. Before pushing, we have to check is stack contains any characters. If stack contains any characters, is the top character of the stack having higher precedence than the operator we are having right now. If the top character is having higher precedence, that character will be popped and will be added to postfix string. The process will be repeated in the same fashion, right now. So here, let me explain. Read the first character A. A. Is it an operator? No. Is it an operand? Yes. If it is an operand, add it to postfix expression. Stack is empty. There are no characters in the stack. Now read next character asterisk. Is it an operand? No. Is it an operator? Yes. If it is an operator, we have to push it onto the stack. Before pushing, we check. Is there any other characters in the stack? There are no characters. If there is a character, we may compare this star with that character. Because there are no characters, we simply push this asterisk onto the stack. Push asterisk. So asterisk will be pushed onto the stack. Stack now contains one operator asterisk multiplication symbol. Then read next character B. So B. Is it an operand? Yes. If it is an operand, simply add it to postfix expression. Stack contains only one character. Then read next character plus. Is it an operand? No. Is it an operator? Yes. We have to push it. Before pushing, we need to compare this with stack content. Is stack empty? No, stack not empty. So stack contains some character or characters. So what is the top character? Asterisk. Is asterisk having higher precedence than plus? Yes. Asterisk is having higher precedence than plus. So asterisk will be popped, multiplication symbol will be popped, will be added to postfix expression, pop, this will be popped and add to postfix expression, then plus will be pushed onto the stack. So now stack contains plus. Asterisk is popped, added to postfix expression and plus will be placed in the stack. Then next character, read next character, see. Is it an operand? No. Is it an operator? Is it an operand? Yes. So because it is an operand, simply add it to postfix expression. Stack contains only one character plus. Then read next character asterisk. Is it an operand? No. Is it an operator? Yes. If it is an operator, we have to push it onto the stack. Before pushing, we compare with this character with the top character of the stack. If top character of the stack, what is the top character? Plus. Plus is the top character, asterisk is the character we read. So we are comparing asterisk with top character plus. Is top character having higher precedence than this character asterisk? No. Plus is not higher than asterisk. So we don't pop any character, simply we push asterisk. Without popping, we push asterisk to stack. Now read next character D. Read next character. What is next character? It is D. Is it an operand? Yes. If it is an operand, simply add it to postfix expression C D. Then read next character. Now stack contains again same plus and asterisk. Read next character backslash 0, which is null character, which indicates that end of the string. We reached the end of the infix expression. There are no more characters. Now just pop all the characters from the stack. There are two characters. Pop, add to postfix expression, add to prefix. Again pop, add to postfix expression. So two times we popped. First time asterisk is popped, added to postfix expression. Next again one more character is popped, that is plus. Plus is also added to postfix expression. So all the characters are added to postfix expression. Now to make it a string, we add one more character backslash 0. See here the postfix expression is A, B, asterisk, C, D, asterisk, plus then backslash 0. This is a postfix expression. Whether this is the correct postfix expression or not, let us check. A into B plus C into D. We wanted to convert. So manually try to convert. A into B will be converted first. AB into C into D will be converted next. CD into. Then assume that this is an operand, this is one more operand, one more operator is there. So AB into CD into plus will be your postfix expression. AB into CD into plus. Yes, exactly same. So the procedure what we have shown in these three examples is proper. Now try to convert, try to explain, I will explain how to convert the infix expression into postfix expression using a program. In a program, the same instructions, whatever the steps we have followed, we apply there. Here, what we are doing, first we are using a stack, we are defining a stack, we are initializing the stack to empty stack. Then we start reading characters one by one. Every time you read a character from the infix expression, the character will be compared whether it is an operand or operator. If it is an operand, just add it to postfix expression. If it is an operator, we have to push it onto the stack. Before pushing onto the stack, the topmost character will be compared. If topmost character of the string is, if the stack is higher precedence than our operator, then the topmost character will be popped and will be added to postfix expression. So I will explain you through algorithm as a program. Let me explain the conversion of infix expression into postfix expression in the form of an algorithm. What is an algorithm? A simple steps or step-by-step process of solving a problem. So here what is the problem? Converting an infix expression into postfix expression. To convert an infix expression, that is a string, into postfix string using a stack. So we have to define a stack. So stack is defined and make it empty. First we have to define a stack, then make it empty. Stack is there, it is an empty stack. Infix to postfix expression, input is infix expression, we are going to find postfix expression. So we are taking two strings, one is infix string, the other is postfix string. Then you have to read characters one by one from the infix expression. Suppose if it is a plus b into c backslash g, it is infix expression. We have to read characters one by one, and we have to perform operation till you read backslash 0, that is null character. So all the characters you are going to read. So while not end of input expression, if it is not end of infix expression, what you have to perform? So read the first character, say for example a, then check whether symbol is an operand or operator. If symbol is an operand, say add it to postfix expression. If symbol is not an operand, that is operator, then if stack is not empty, then if precedence of top symbol in the stack having higher than symbol, then the top symbol of the stack will be popped and it will be added. As long as stack is not empty and top symbol is having higher precedence, that symbol will be popped and will be added to postfix expression. Then our symbol, whatever we read, that will be pushed onto the stack. This procedure is repeated for all the characters of input expression. Finally, once you reach backslash 0, all the characters that are available in the stack, that is till stack is empty, you pop all the characters, add the characters one by one to the postfix expression. So this is the algorithm. Again, let me explain the complete program. Explain the C program to convert an infix expression into postfix expression. To convert an infix expression into postfix expression, we have to utilize a stack. So let us declare a stack first. Define stack. Stack is nothing but combination of an array and uh, pointer pointing to topmost character. So here is the collection of two fields. One is an array and top. Top is the variable which holds the position of topmost character that is placed in the stack. So with the two parameters we define a stack. So character entry max stack, where entry is the name of the array, max stack is total number of characters that you can place in the stack. So here we have already seen stack is going to store operators. Operator is plus, minus, asterisk, division, etc. So these are all characters. So we are going to store characters in the stack. So character. So type is character. Then top. Top is the position of topmost character in the stack. So it is always integer only. So it is the collection of two fields, array, that is string, and top. Then type definition, struct stack, stack type. So we can redefine, that is struct stack, as stack type. From here onwards, you can use stack type instead of using struct stack. Then once you define a stack, you have to think of the operations. So what are the different operations that you can perform using stack? It is push, pop, empty. In the previous example we have discussed, we are pushing some value, we are popping some value, we are checking whether stack is empty or not, and we are getting some character from top of the stack. So all the four functions are defined in here. Push function, pop function is empty, then finding topmost character from the stack. Say first let me explain about push. Push s comma x. S is stack type, stack, then x is the character we are pushing. So plus you may push, minus you may push, asterisk you may push, divided you may push, and dollar you may push dollar. Here we may use dollar for exponentiation symbol. So addition, subtraction, multiplication, division, exponentiation. Suppose I wanted to push x. What is x? X may be plus, minus, asterisk, or divided by, or dollar. So initially increase top and place element in top of the stack. Top is top plus 1. Entry of top is x. As top and entry are members of stack, that too a structure, that too a reference parameter, that is a pointer to stack. So S arrow top is S arrow top plus 1. SRO entry of SRO top is X. Then pop. Pop stack. Pop means removing one element from the stack. Removing topmost element from the stack. So stack contains already some characters we have discussed. So stack contains some characters. The topmost character you are going to be returned or removed. So here entry of top is assigned to X. Entry of top is assigned to X. Then top is reduced by 1 or decreased by 1 and X is returned. Entry of top. Entry and top are members of stack. That too, if you apply pop, the stack will be modified. Before, if stack contains 4 characters, after applying 4 pop, stack contains 3 elements only. So you are going to modify stack. So during push, during pop, stack is getting modified. So the stack parameter is taken as a reference parameter, that is pointer. If you use reference parameter, the content will get changed. So in a pop, entry of top is assigned to X, top is reduced by 1 and element is returned. So top reduces its top value, pop reduces top value and the topmost character is returned. That may be used for some other purpose, right? Then empty stack. Empty means empty of stack. Whether stack is empty or not, we are going to check. So this empty function returns either 1 or 0. It returns 1 if stack is empty. It returns 0 if stack is not empty. Empty function returns 1 if stack is empty. Empty function returns 0 if stack is not empty. It is returning an integer. What is this integer? It may be 1, it may be 0. So how it is returning 1, how it is returning 0, let me see, explain. So if top is minus 1, returns 1. Otherwise, returns 0. Top is minus 1 means stack condition, stack empty condition. So if top is pointing to minus 1, it returns 1. Yes, it is empty. Otherwise, it returns 0, not empty. Then stacked up. In the previous examples, what we have checked, every time you read a character, you may check whether it is operand or operator. If it is an operand, you push it onto the stack. If it is an operator, you have to compare this operator with the top operator or the top symbol of the stack. So what is the top symbol? You have to check. So you have to get the top symbol. You have to get the top symbol means you have to pop normally. So normally if you pop, it will be removed. So without removing, you wanted to compare your symbol with top symbol, you may utilize this particular stack top. You are not going to modify the stack, but you are utilizing the topmost symbol. So that's why I'm using this parameter as not as a reference parameter. It is used as a value parameter only. Here it is considered as just a structure. Here it is considered as a structure to pointer, pointer to structure. So here whatever you are using S dot entry because it is an ordinary parameter. Here S is used as an asterisk, that is S arrow top. Whenever you use a normal structure, the members are accessed using S dot top, S dot entry. If it is a pointer to structure, the individual parameters are accessed using arrow mark, S arrow top, S arrow entry. So entry of top is your topmost character that is going to be returned. You are not modifying your stack, still you are utilizing what is the topmost character. Then every time you read a character, you have to check whether that character is an operand or operator. See, from the infix expression, you are going to read characters one by one. Is the character operand or operator? You have to check. So there is a function called isOperand which returns an integer. So this function is returning an integer. So this integer may be 1, maybe 0. 1 for true, 0 for false. Means you are passing a character to this is operand function. You are going to check whether this character is operand or operator. What is the infix expression? For example, a plus b into c is my infix expression. I may read a. I have to check whether it is operand or operator. I may read plus. I have to check whether it is operand or operator. I may read B, I have to check whether it is operand or operator, etc. So every time you read a character, you have to pass this character to is operand function. So for example, if A is passed, if CH is A, if CH is A, so it is supposed to return 1 because A is an operand. So whether it is passing 1 or not, let me explain. CH is A. Is CH equal to plus? No. Is CH is equivalent to minus? No. Is CH equivalent to asterisk? No. Is CH is equivalent to backslash? No. Is CH equivalent to exponentiation? No. Then if it is not equivalent to any of these characters, it returns 1. If it is equivalent to any of these characters, it returns 0. So if it is an operator, it returns 0. If it is an operand, it returns 1. So A is an operand, it returns 1. Suppose if it is plus, if CH is plus, if CH is plus, then CH is plus. If CH is plus, yes it is. So it returns 0. Means 0 will be returned if the character is an operator. 1 will be returned if the character is not an if it is an operand, right? 0 will be returned if it is an operator. 1 will be returned if it is an operand. So A is an operand, plus is an operand. If you input A, it returns 1. If you input plus, it returns 0. If you input B, it returns 1. If you input asterisk, it returns 0. If you input C, it returns 1. So 1 for operand, 0 for operator. In the previous examples, we during conversion of infix expression to postfix expression, we used to read characters. If the character we read is an operator, we have to compare this operator with the top symbol of the stack. If top symbol is having higher precedence than this operator, top symbol has to be popped, added to postfix expression. So we need to compare two operators which is having higher precedence. So we use a precedence function. We input two operators, operator 1 and operator 2. Suppose if operator 1 is asterisk and operator 2 is plus, this function is going to return an integer int. Int, it may return 1 or it may return 0. 1 means precedence of operator. Operator 1 is greater than operator 2. 0 means operator 1 is less than operator 2. That is, operator 1 is having higher precedence. Here operator 2 is having higher precedence. So let me explain. So there are two operators. We have inputted two operators. Say operator 1, operator 2. Then check. Is operator 1 is having higher precedence or operator 2 is having higher precedence? So normally, see when operator 1 is asterisk. If operator 1, is it exponentiation? No. Is it asterisk? Yes. So assume that precedence is 2. See, then operator 2, switch operator 2, assume that it is plus. So plus is plus, precedence is 1. Precedence 1 is 2, precedence 2 is 1. Is precedence 1 greater than precedence 2? Yes. 2 is greater than 1, so it returns 1. So asterisk is greater than plus. For example, if operator 1 is plus and operator 2 is asterisk, then when operator 1 is plus, what happens? What happens? Plus, it is 1. So PR 1 is 1. Then operator 2 is asterisk. Asterisk means 2. PR2 is 2. Is PR1 greater than PR2? No. So it returns 0. That is, plus is less than asterisk. Plus is less than asterisk. So this function is going to return either 1 or 0. 1 is first operator is greater than second operator, or the precedence of first operator is greater than second operator. Priority of first operator is greater than second operator. So it is nothing but priority. So what is the priority of first operator? What is the priority of second operator? Then the difference. If the difference is greater than 0, it returns 1. If the difference is not greater than 0, it returns 0. So here normally we use exponentiation, asterisk, division, plus, minus. exponentiation having higher precedence. Say, let us have 3. Into and division same precedence, plus and minus same. So there are 3 kinds of operators. So exponentiation considered as 3, into division as 2, plus minus as 1. Find out what is the priority of operator 1, what is the priority of operator 2. The difference of priority is maybe greater than 0 or less than 0. So is the priority of first operator is greater than second operator, then return 1, otherwise return 0. So actual conversion function, infix to postfix expression. So I am passing ifix and pfix to the function. So ifix infix expression, I am going to find out what is postfix expression. This is input, this is output. Input, output. Infix expression, postfix expression. For example, if this is the infix expression, I am inputting to this function. So this function is going to return you the postfix expression of this inputted infix expression. For example, you wanted to convert this infix expression into postfix expression. First of all, you have to define a stack. S is your stack. What is S? S is a stack consisting of an array and top. Then ifix and pfix, infix expression input and pfix is postfix. Both are arrays. Both are arrays. To access these arrays, we need indices. I is index to access infix expression, ifix. J is the index of postfix expression. Just assume that I is used as index of infix expression, j is used as index of prefix expression. Both are arrays. So to access these arrays, we need index I and j. So to access infix, to access prefix, I and j are used respectively. Then initially, after defining the stack, make stack empty stack. Empty stack. Empty stack means top is -1. So stack is empty. Initially stack is empty. Then for I assigned to 0, symbol ifix of I not equal to backslash 0 I plus plus. So first statement. First statement means this is a loop where some number of instructions are going to be executed repeatedly some number of times. How many number of times? For I assigned to 0, we start from index 0, that is I is 0, index of infix expression 0. Then is index of 0, ifix of I is the 0, ifix of 0 which is A. Is A is your symbol now or you make character. Is it not equal to backslash 0? Is it end of the infix expression? So till end of the infix expression you are going to repeat. Starting from 0th character, you are going to check every character till null character. So you are going to read A asterisk B plus C asterisk D, then backslash 0. Till you read backslash 0, there are some instructions to be executed. Assume that I is 0. I is 0 means symbol is A. Symbol is A. Is operand symbol. Is symbol is an operand? Is A is an operand? So it is operand function, already we have explained. I have passed A. A is an operand, it returns 1. If it is 1, just prefix of j plus plus symbol. So here postfix expression is taken. So here postfix expression initially j is assigned as 0. So each time you read a character from infix expression, decide whether it is operand or operator. If it is an operand, just add it to postfix expression. That is, you are going to add your next instruction from location 0. So A, you are going to add A into postfix expression. So A is added. Stack is still empty. There are no characters in the stack. Then read I is increased. So you are going to get the next symbol. Symbol is now asterisk. Again you are going to compare is operand symbol. Is symbol operand? If the symbol you read is an operand, no, it is not an operand, it is an operator. So if it is an operator, see here what you are doing. Else, if it is an operator, is stack empty? No. Yes, it is empty. Is stack empty? Yes, stack is empty. So without checking these instructions, you are going to execute push symbol onto the stack. The symbol you are reading, you are going to push it onto the stack. So asterisk is pushed onto the stack. Push asterisk. So now stack contains asterisk. Postfix is A, stack is asterisk. Then I is increased. You read next symbol. Symbol is B. Is operand. Is B operand? Yes. So we are inputting B to is operand function. It returns you 1, that is it is an operand. Because it is an operand, add it to postfix expression. Already you have inputted A at location 0 and in the next location you are going to add B. So postfix is AB and stack contains only one character, that is asterisk. Then again I is increased by 1. So next is 2. You are reading B. Now B is operand, say B is operand. Is it operand? Yes, so add it to postfix expression. Then next character is 3 plus. Plus is symbol plus? Yes. Is the symbol is plus. Is it an operand? No, it is an operator. If it is an operator, else part. While stack is not empty, yes, stack is not empty, stack contains asterisk. So the symbol you read is plus and stack contains some characters, it is not empty. So top symbol is going to be compared with this symbol using precedence function. Is stack empty? No. Precedence of top symbol and symbol. This is top symbol and plus is symbol. So asterisk plus. Asterisk is having higher precedence than plus. So it returns 1. So these two statements are going to be executed. Top symbol is pop. Pop the stack. Stack is popped and that is added to postfix expression. Then push symbol to stack. Plus is pushed onto the stack. A into B is your postfix expression and plus is stored into or pushed into stack. Then again I is increased by 1. Now I is C. Is C operand? Yes, it is. Push it onto the stack. Add it to postfix expression. C, you read C. Add it to postfix expression. Stack contains plus. Then increase I value 5. So whenever I is 5, automatically symbol will be asterisk. Symbol is asterisk. Is it an operand? No, it is an operator. Now else part. Is stack empty? No, stack is not empty. Stack contains plus. Stack contains plus. The operator here it is asterisk. Is top symbol is having higher precedence here? We are checking precedence of plus and asterisk. Top symbol is plus. Symbol is asterisk. The operator we read is asterisk. Is top symbol having higher precedence? No. Plus is not higher than asterisk. So no need to pop. Simply push it onto the stack. Without popping, you are pushing asterisk. So now stack contains two operators, plus and asterisk. Then read next character D. Is it operand? Yes, it is an operand. Yes, it is an operand. Just add it to postfix expression. Then once again read next character backslash 0. See here, if the symbol you read is not backslash 0, perform this process. Otherwise, see that program, the first statement will be terminated. Then once you terminate this first statement, there is one more process you have to perform. While not empty, while stack is not empty, is stack empty? No. Once you reach backslash 0, you check stack is not empty. Stack is having two parameters. So you are going to pop characters from the stack. Asterisk is popped, added to postfix expression. One more character is there, plus that is also added to postfix expression. Then after adding all the characters, one more character also will be added to postfix expression backslash 0 to make it a complete string. Now it becomes AB into CD into plus backslash 0. So this is your postfix expression. The whole process is your infix to prefix algorithm or function. So this entire program is just like a modular programming. What is modular programming means? A big problem is divided into so many sub problems. Each sub problem is going to be solved using a small function, and by combining all these functions we can get the solution of the original program. So original problem. So dividing a problem into sub-problems, solving the sub-problems using smaller functions, by combining all these functions to get the solution of the original problem is said to be modular program. So you have to understand this program, the procedure. This procedure is just like simple steps. Each sub-problem or the procedure of so many sub-problems, and each sub-problem is solved just like is it an operand, push the character, pop the character, get the topmost character, find the precedence of character, and convert all these used in the infix to postfix expression. So this is the actual algorithm, that is infix to postfix expression. And then one more function will be there, main function. In the main function you may read the infix expression and you may call this infix to postfix expression, where we pass infix expression and we find postfix expression, and the postfix expression will be printed. Thank you.